In today's lesson, we are going to be doing a review of the personal finance unit. So the first thing we're going to do is look through the different formulas that we learned, some key concepts or terminology, and then we'll get into some example questions. So the first equation we looked at is simple interest. Simple interest was the formula I equals PRT. I represented the interest earned or owed, depending on what the situation was. P represented the principal, which is the initial amount, or your starting value. Initial amount. So basically how much you're starting with or how much when you're saving. R is the rate as a decimal. And T is the time in years. So that was our formula and what the variables represented. We also talked about using a magic triangle to help us determine the other equations, or to help us determine what equations to use to find the other variables. So for example, we know that we're solving for I, or this equation over here is solving for I. So the way it works in the triangle is you cover up what you're looking for. In this case, if I'm looking for I cover it up. I'm just highlighting you to show it. And then what's remaining, PRT, is what you have to do. So in this case, P times R times T, which we can see in our formula. If I wanted to say find P, I would cover it up. My formula would then be I divided by R times T. And it works for every other variable or any variable that you're looking for. And again, you can always go back to the previous lessons as well that talk about simple interest. Moving on to compound interest, we had two formulas. The first one was the future value. A represented the future amount or future value. And this was essentially your principal plus the interest, right? Because the amount you're going to have in the future is going to be how much you started with plus the interest. P, again, was your principal, which was the initial amount, I was your rate as a decimal. But different from simple interest, what we had to do was we had to divide it by the compound number. And that is a step that a lot of people tend to forget. You do have to divide your rate or your percentage as a decimal by the compound number. And we'll talk about those later. N was the number of years multiplied by your compound number. So those are two things that you have to do, or two small calculations that you have to do before you get into the actual formula. Compound interest, looking for present value. So if we wanted to find out how much we had to start with, or how much we need to invest now or save now, or have today, we would use this formula to find the present value. So A, again, still was our future amount. P was our principal or initial amount, or present value, you could say. I was our rate as a decimal, and then divided by our compound number. So exactly the same variables as the previous equation. And actually, it's the exact same equation, just rearranged to solve for P instead of A. So that means that N is our number of years multiplied by the compound number. And the compound number comes from these different terminologies, because each one of these terminologies represents a certain value. Semi-annually means twice a year. Quarterly means 4 times a year. Annually means once. Weekly is 52. Daily is 365. Monthly is 12. And bi-weekly, or every other week, is 26. So all these numbers here, these all represent the compound number. So when we talk about in our previous variables, multiplying by the compound number or dividing by the compound number, these values down here under the terminology, these are the compound numbers that we're talking about. And it will be clear in the questions what you have to do or what the compound number is. So let's look at a couple questions. So number 1 wants us to show the interest rate as it would appear in the formula for simple interest. Again, the key thing here is simple interest. So all we have to do is take the rate and turn it into a decimal. And you can do that by taking the percentage, so 13, and divide by 100. To get your percent to a decimal, divide it by 100. So 13 divided by 100 is 0.13. 0.5 divided by 100 is 0.005. So that's how you would find the interest rate for a simple interest question. 2, how much, or calculate how much simple interest is earned if $2,000 is invested at 4% for 5 years. So we're looking for how much interest is earned. Our principal, or what we're starting with, is $2,000. The rate is 4% for 5 years, so our R is 4%, which is 0.04. We divide it by 100. And our time in years is 5. So our formula then, I equals PRT equals 2,000 times 0.04 times 5. So 2,000 times 0.04 times 5 is $400. So that means you're going to earn $400 in interest. The second part of the question, how much is the investment worth? Well, that's the total amount. So essentially what we're looking for is the future value, or A, which is equal to your principal plus the interest. So in this case, A equals 2,000, which is what we started with, plus 400, which is what we earned in interest. So in the end, we have a total of $2,400. Three, what principal is needed to have $500 in interest in 2 years invested at 2.5% simple interest? So because it says simple interest, that should tell us what equation we are using. Because it's asking for what principal, well, that means we don't know our p-value. Our I-value, how much interest do we have? Well, the question tells us $500 in interest. So we know I is 500. T is 2 years, and we know our rate. 2.5 divided by 100, 0.025 is our rate. Because we're looking for P, we should be using our magic triangle because it's going to be a little bit different. So if we're looking for P, let's cover it up. So that means P is equal to, and what's uncovered is I divided by RT. So that's the formula that we're going to use. We can plug in the information that we have now. So 500 divided by 0.025 times 2 will tell us how much we should have initially. So 500 divided by 0.025 times 2 . So that means we should have $10,000, or we should start with $10,000 so that we earn $500 in interest. 4, what interest rate is needed to have $4,000 double in 10 years? So again, it doesn't say simple interest, but we can assume it does, and we'll see once we get to compound interest why that's the case. So again, we know we're dealing with I, P, R, and T. We're looking for the interest rate, so it tells us what is the interest rate. So that's what we're looking for. Needed to have $4,000 double in 10 years. So we know our T, or time, is 10. We want to have $4,000 double, so we know we're starting with 4,000, so that's our P value. But what's our interest? We can think about it. If we want to have $4,000 double in 10 years, how much interest do I want to earn? If I want to double it, that means I want to earn $4,000 in interest, so that in the end, I would have a combined $8,000. So that means my I is 4,000. Because I'm looking for R, I'm going to use my magic triangle. If I cover up R in the middle, that means that R equals, left with I over, and we see P and T on the bottom, so I divided by P times T. So R equals 4,000 divided by 4,000 times 10. R equals 0.10, and this is the decimal version, so therefore the rate is actually 10%, because 0.1 represents 10% as a percentage, so 10% is 0.1 as a decimal. Number 5, now we're moving into compound interest. So number 5 is going to be a little different because now we want to calculate the I value as it would appear in a compound interest formula. So again, remember compound interest, we go back to that first page, the I value was the rate divided by the compound number. So here we have 6% semi-annually. And semi-annually, remember that term represents a compound number of 2. So if I want to find what my I value is, I take the rate, or 6%, as a decimal, so 0.06, and divide it by the compound number, which is 2, so I is 0.03. Basically, I'm finding the interest per compounding period. So because I'm earning interest twice a year, that 6%, which is for the entire year, needs to get broken down into 2 parts, one for each half of the year. For B, 5% weekly, so it's 5% the entire year, and I want to figure out how much is it every week, because it's compounded weekly. So I take 5%, 0.05, and divide it by 52, because there are 52 weeks in a year. So 0.05 divided by 52 equals 0.000962. So in some of these questions, you may get very long decimals. Try to keep at least 3 numbers. So when you're going through in your decimals, so we have 000, then 962. So try to keep at least 3 numbers, so the 962 would be our 3 numbers. Because if you round it too early, it will change your actual value in the end. 6 says to calculate N as it would appear in the formula for compound interest. So this was the second part that we had to calculate before we could get into the actual questions. So for A, compounded quarterly for 5 years. So again, compounded quarterly means 4. And the reason we need this is because, again, I'll write it down here, N equals the number of years multiplied by our compound number. So again, that compounded quarterly tells us that the compound number is 4. So in this case, N equals number of years, so 5, times 4, n equals 20. So essentially what that's saying is if it's compounded quarterly, that means I earn interest 4 times a year. If I earn it 4 times a year and I'm saving for 5 years, in total, that's going to be, I'm going to earn interest 20 times. For B, it's biweekly, which means 26 times a year. So n equals 2 times 26, n equals 52. So what we just did in question 5 and 6, these are the two small calculations that you would have to do prior to using your compound interest formula. And we'll start to see that as we go into those questions. So in number 7, calculate the amount of an investment if $500 is invested at 3% compounded quarterly for 3 years. So here, this is what we mean by in a question. You'll see that it says compounded, let me just go back to yellow. It says compounded quarterly. That means we're using compound interest because of this key part here, the compounded. If it's compound interest, it will say that. So because it's compound interest, we know we're going to be using A, P, R, and T. A is our future amount, and because our question is asking us to calculate the amount of the investment, that means we're looking for how much is it going to be in the future. P is our principal, or how much we start with. In this case, we're starting with $500. Sorry, it's not R and T, it's I and N. Again, that's just what we calculated just above. So for I, we need to take the percent, 0.03, divide it by our compound number. Quarterly means 4. So 0.03 divided by 4 is 0.0075. N is the number of years. We see here. So 3 years times the compound number, which is 4. So n equals 12. From there, we have our formula. A equals P, 1 plus I to the power of n. So A equals $500 times 1 plus 0.0075 to the power of 12. I would recommend solving the bracket first because we have to use our bed mass. So brackets first. $1.0075 to the power of 12. And now this, if you're comfortable with it, you can do it all at once on a calculator. Or if you're not, do the exponent first. So do 1.0075 to the power of 12 and then multiply by 500. 546.90. And for your final answers, because we're dealing with money, keep it to 2 decimal places. So that's how much we'll have in 3 years. The second part, how much interest was earned on the investment. If I know that this is the final amount, and I want to figure out how much did I earn, I know how much I started with, so the amount of interest earned is equal to the final amount minus how much I started with. So $546.90 minus what I started with was $500. I get $46.90 is the amount of interest earned. Eight and 9 are again the same types of questions. So again, looking at the compound interest, looking to see how much you're going to have in the future. So I suggest pause the video so you can try these on your own, and then we'll come back with the full solutions. So coming back to these two questions, we see in number 8, Jenny deposited $500 into an account, so that tells us how much she's starting with. That paid 7% interest, so it does tell us part of our rate. Compounded semi-annually. So right off the bat, compounded means we're using our compound interest formula. The semi-annually, that's again the key word that tells us how much or what the compound number is. If she leaves it there for 10 years, so again telling us the time, how much will she have? So again, that should be enough to help us figure out our P, our I, and our N. We're using our compound interest formula. We plug it in, and when we work through and calculate, we should get $994.89 is how much she will have after 10 years. If we move on to number 9, Gary wants to buy a car. He finds a Ford Fusion for $14,500. That's going to be our initial amount because we're borrowing money this time. The dealership is offering financing at 3.1% per year, compounded monthly. So the compounded monthly, that tells us again compound interest as well as the compound number. For 5 years, what is the future value? So it tells us we're looking for the future value. So that's our A value that we're looking for. The P again was how much the car was worth. The I and the N we can get from using the rate, the compound number, and then for N, it's the number of years and the compound number. Plugging that into our present value formula, we should then work our way through to get that in the end, the final amount of this loan is going to be $16,924.28. Number 10 asks what principal must be invested today in order to grow to $2,000 in 3 years at 5% per year compounded annually. So this question is a little different. It does say compounded, so we are using compound interest, so we know at least that for our variables it's A, P, I, and N. A is the future amount. In this case, I want to know how much needs to be invested today to grow to $2,000 in 3 years. So that grow to $3,000 or $2,000 is key because the $2,000 is how much I'm going to have in the future, which is my A value. P, I don't know because the question is what principal must be invested today. So anytime you see a question that asks how much do you need today, what's the present value, how much do you need to invest now, that should be key because that tells us we're looking for the principal. Our I is 0.05, or the rate divided by the compound number. Because it's annually, the compound number is 1, so it stays at 0.05. N is 3 years, multiplied by the compound number, which is 1, so it stays at 3. So this means I am using a slightly different formula. And again, it's on the front page, or the very first page under the key points. It talks about looking for present value and compound interest. So P equals A divided by 1 plus I to the power of N. P equals 2,000 divided by 1 plus 0.05 to the power of 3. P equals 2,000 divided by 1.05 to the power of 3. And in the end, I get $1,727.68. So that means that I need to invest $1,727.68 so that after 3 years of investing it at this rate, I will get $2,000. So again, this focuses on, again, using simple interest, compound interest, and in the two forms of looking for the future value and present value. Again, if you need further explanation on this, please go back to the specific lessons on these concepts.